So this is the 2014 Leave Insert Ordinary Level Paper 2. We're looking at question number 5. Part A. The square ABCD has an area of 81 centimeters squared. Find the length of AD. So these straight brackets mean the length of AD. So we need this distance from A to D. Well, if the area of the square is 81 centimeters squared, the width or the length will be the square root of that. So the square root of 81 will be 9. So AD, the length of AD, will be 9. All the sides will be 9 centimeters. Part B, a sector of a circle with center B, so you can see here, and radius BC, so here's the radius, is drawn into or inside ABCD as shown by the shaded region. Find the area of the sector, correct to one decimal place. Okay, so this sector is basically 1/4 of a circle. So if I find the area of the full circle and divide by 4, I'll have the area of the quarter circle. So the area of a circle or a disc is, in your tables book, it's pi r squared. So pi r squared is the full circle. So full circle. So the radius is BC, which we found would be the same as AD, which is 9. So that's pi 9 squared, which is 81 pi. So then the quarter circle will be the 81 pi divided by 4. When we do that on our calculator, we get 63.617, and on it goes. But we want it correct to one decimal place, so that's going to be equal to one decimal place. We look to the second digit after the decimal. This doesn't affect the 6 in the front, so it's 63.6 will be the area, and that's centimeters squared. Okay. Moving on, part C, part B2 rather, a second sector of a circle, center D, and radius dA is drawn. So here's the second sector drawn. Find the area of the shaded region, the overlap of the two sectors, correct to one decimal place. So we've defined this shaded region here. Well, what this can be thought of as the area of the square minus this region and this region, which are the same. So it's the area of the square. So the area of the square, if you remember, was 81. That was given in the question. The area of the square is 81. So it's 81 minus these two regions here. Now, to find one of these regions, if we look at the last question, that's the same as this region here. We want to know the area of this. It's 81 take away the shaded region, which we just found. So 81 take away 63.617, right? So we'll just do that first. So 81 take away 63.61, so on. That gives us 17.4 roughly, okay, or to one decimal place. So we're going to be taking 2 of those away for this region in the middle here. So it's 81, the total area of the whole square, minus these 2 blue regions. So minus twice this here, 17.4. So what that gives us then is 46.2 centimeters squared. So that's the area of this region in here, correct to one decimal place. Okay, finally, part C. The point P is on the arc of the sector DAC. So we see the point P here, as shown. The triangle APC, so APC, the shaded one, is isosceles. Okay, so AP and PC are the same length. Find the area of the triangle APC, correct to 1 decimal place. Okay, so the area, remember the area will be the base by the perpendicular height. So in this triangle, if we take this line as the base, and then if we take the perpendicular height as this line here. So in other words, imagine we drew a line from here to there at 90 degrees. So half the base by the perpendicular height, so half the blue by the green. If we knew that, we could find the area of the shaded region, the triangle. So, right, well, if we're trying to find the blue line, you can see this triangle here, ADC, is a right angle triangle. So the triangle, badly drawn there, but in the triangle ADC, it's right angled. We know this side's 9 and this side's 9. So if we want to find AC, which we'll just call x, we can use Pythagoras. So Pythagoras says that x squared is equal to 9 squared plus 9 squared. The hypotenuse is equal to the sum of squaring the other two sides. So that gives us x squared is equal to 81 plus 81. So x squared is 162. So x is the square root of 162. So that's our blue line. So now we know the blue distance. Just highlight that in blue. So now we just need the green. Okay, well, the green, we can think of the green as the distance from P to, if I extend this line back here to D, right? This distance here, just from D to the center, will be half of AC, half this diagonal, because this is another diagonal here. So D to the center will be half of AC. So if we call the center O, D to O, so the distance DO will be half of this, so half of root 162. So half of root 162. And by the way, root 162 simplifies to 9 root 2 on the calculator. So it's half of 9 root 2. So half of 9 root 2, yeah. Half of 9 root 2. So that's D to O. And we know that D to P, so D to P is actually just the radius of this arc, which happens to be the side, 9. So D to P, the length dP, is 9, the radius. So the green length then, PO, or OP, will be the PD minus DO, or DP minus DO. So it'll be the 9 minus half of 9 root 2. So that's going to give me PO, which is the green distance that I'm looking for. So that's my green distance. So I have my blue distance and my green distance. So now I'm just going to sub them into the formula for the area of a triangle. So the area of the triangle is half the base, so the base is the blue one. So the area of the triangle is half of 9 root 2 by the perpendicular height, which is this. So multiplied by 9 minus a half of 9 root 2 divided by 2. So half the base by the perpendicular height. Or sorry, not divided by 2 because we've got half here on the outside. So half the base by the perpendicular height. So just to be clear again, this is my perpendicular height. This is my base, and it's half of that. So when I put all of that then into the calculator and press the SD button, I get an area of 16.8. Well, that's going to be centimeters squared. Now that's correct to one decimal place, so it's 16 point something, but it was 0.8 correct to one decimal place. So that's the end of question number 5.